let's continue to use Java to solve Leetcode problem. So now let's just try to solve Leetcode problem 21, merge two sorted lists. So we are giving the hands of two sorted linked lists, which is the list 1 and list 2. And we should know that this is a linked list. It is not array. So we're going to merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists, return the head of the merged linked list. So this is going to be a very famous problem. So all those two lists are not array. We can see the input, it is array, but actually this is a linked list. And for this linked list, all the numbers are sorted in increasing order, and we just need to merge them. And after that, the linked list gonna be sorted in increasing order as well. If both of them are empty, as we can see, we're gonna return none. This is not an empty array. We're gonna return none. Yeah. If one of them is none, another of them have a number, we're gonna return only one node. So how can we solve this problem? So first of all, we need to say what is the feature for the list node class in Java. We can see that it has a value, it has next, and yeah, it also has the empty definition, and we can also put a value inside. Yeah, and also we can put a value inside, and we can also put the next node inside. So definitely there are three different kind of definitions of the list node. Yeah. Now let's just try to solve it. So we're gonna prepare the list node. So we're gonna use L1 to represent the list node 1. Yeah. So L1 gonna equal to the list 1, and we're gonna define list node L2 gonna equal to list 2. I just want to reduce my typing of the list 1 and the list 2, because later on I'm gonna directly use L1 and L2 to represent list 1 and list 2 respectively. Now I need to prepare a dummy node. So the dummy node we're gonna new, because we're gonna use the list node class, so we're gonna new a class which is the list node. So it's gonna be the list node, and inside we can have a value or not. Because this is just a dummy node, we will not use the value, so we will not put a value. Even we put a value like 0 inside, it doesn't matter. Yeah. Now we're gonna prepare another pointer. We're gonna call it list node p. We're gonna equal to the dummy node, because currently we're gonna use this pointer p directly. After that, we're gonna return dummy dot next. So this is the final result. But before that, we need to check if there's some value inside. So for example, we need to check if L1 not equal to a noun, and L2 not equal to a noun. So this means that there must be some value inside the list 1 and the list 2. So this means we can compare them together, because we're gonna we are using the AND to check. If L1 is not empty, L2 is not empty, and we're gonna compare the value. So if L1 dot value is less than L2 dot value, this means we're gonna use this pointer p. So p dot next gonna equal to a new list node, and inside it's gonna be the smaller value, L1 dot value. And we need to update the pointer for L1. So L1 gonna equal to L1 dot next. Similarly, we need to prepare if L1 dot value is bigger. Yeah, so this means L2 dot value is smaller or equal. Yeah, we just need to copy and paste. So let me just copy and paste and change it. So here gonna be L2 dot value, and here gonna be L2. Gonna update it to L2 dot next. But anyway, we need to update the pointer p. So p gonna equal to p dot next. But this is not yet finished. So this is for the situation if we compare L1 and L2. If we consumed all of them, Yeah, so for example, L1 has 3 nodes, L2 has 3 nodes, we consumed all of them, we don't have any node. But what if we have more node for L1 or L2? We have to check it separately. So now we need to check this case. So I mean, after consuming L1 and L2, or maybe there's some node inside L1, or maybe there's some node in L2, or maybe there's nothing left in L1 or nothing left in L2. We must check this case. But how can we check that? But this case for the number gonna always be bigger. For example, this is for this gonna be 5, 6, 7. And here, this is for this maybe 8, 9, 10. Yeah, it must be some numbers which is bigger than the last node, the value of the last node. So now we're gonna check this case. So we're gonna check p dot next gonna equal to L1 or L2. But we need to check. Let's just use L1. If L1 not equal to none, so this means we're gonna get L1. Otherwise, we're gonna get L2. Yeah. So let's just use a question mark. Yeah, if L1 not equal to none, we're gonna choose L1. Otherwise, we're gonna choose L2. Yeah. So basically, that's all about it. Now let me just run it to check if there's any issues. Yeah, as you can see, I passed all the testing cases. Now let me just submit it to check if it works. As you can see, it works and it's pretty fast, and the time complexity is ON. So here this ON means the length of L1 plus the length of L2. So maybe we're going to say the time complexity is OM plus N. And the space complexity is OM plus N as well, because we prepared a dummy node and we're gonna link all those nodes together. So the space and time complexity are both OM plus N. I think that's all about it. Thanks for watching. See you next time.